So today we're going to look at adding and subtracting fractions and mixed numbers. This should mostly be a review from elementary school, but we want to spend a little time just making sure we have these skills down. This is covered in pages 33 and 34 of your term notebook, so go ahead and turn there so you can follow along. The first couple of examples will be on the board, and then we'll get into the actual notes. So I want to start with some models and just looking at how they can show us, what they can show us about adding and subtracting. So the first one shows 2/7 plus 4/7. And if we put those together in the same model, we can see 1, 2, 3, 4, 5, 6, 7. So we have 6 pieces out of 7. If we look at another problem, 1, 2, 3, 4, 5 sevenths plus 1, 2, 3, 4 sevenths. That's going to give us 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces with 7 being in each hole, and as you can see, that's actually 1 and 2 sevenths, just like we've been talking about with fractions and mixed numbers. Looking at our next one, we can also subtract fractions similarly. We have 4/5 minus 3/5, and when we show that in a model, if we had 4/5 and we took away 3 of them, we would have 1/5 left, 1 piece out of 5 pieces. Now this one's a little different because when we look at this, we have 1/2 plus 1/3. And the problem is when we get over here to the answer part of it, we have 2 pieces, but it's 2 out of what? And the bigger problem is they're not the same size. So we got to rethink what we're going to do. If we take and we rethink of that 1/2 as 3/6 and the 1/3 as 2/6, notice they now have the same denominator, meaning both of the wholes have the same number of pieces. That makes the addition much easier. Now we have 1, 2, 3, 4, 5, 6, and that was easy to add. Now what that hopefully reminds you of is that anytime you're adding and subtracting fractions, the very first thing you need to do is find a common denominator. Then decide whether you're adding or subtracting, and it's very similar to doing whole numbers. So we start on the right-hand side of the problem with the fraction part of it. We add the fractions. When we add the fractions, we always have to add the numerators, which we saw, and keep the denominator. Then remember that you always reduce fractions, and if it's an improper fraction, we might have to carry. That's a possibility. And then, of course, once we've dealt with the fraction part, then we deal with the whole numbers and adding those. If it's a subtraction problem, just like with whole numbers, we start on the right-hand side, which would be where the fractions are, so we need to subtract the fractions. Remember, when we're subtracting the fractions, we subtract the numerators to keep the denominator, just like what we saw in our models. And then sometimes with subtraction, as you know, you might have to borrow to even be able to do that, and we always reduce our fractions. And then once we're done with the fraction part of it, we go to the whole number part. So let's look at a couple of examples. These are on page 34 in your term notebook, so turn there now and start working. And make sure to work along with me. So our first example is 7/8 minus 5/8. I like to write my problems both up and down because then if you need to find a common denominator, you can do that off to the right. We don't need to in this one because, yay, we already have a common denominator of 8. So we look at this and we do 7, and make sure to pay attention to subtraction. 7 minus 5 is 2, and our denominator stays the same. 2/8 we can reduce to 1/4 because we can divide both numbers by 2. Our next example is 4 3/8 plus 5 1/4. Now remember, I said I always like to look at just the fraction part of the problem before I ever look at the whole number side. When I look at this, I can see that 3/8 and 1/4, they do not have a common denominator. So that's the first thing I need to do. I got to find something that I can change in both two equivalent fractions that have the same denominator. But this one's actually pretty easy because 4 goes into 8, so I can just make these both 8s. So this one's going to stay 3/8. This one is going to become 4 times 2 is 8, and then 1 times 2 is 2. It's going to become 2/8. Remember, we are adding in this case. So 3/8 plus 2/8 is 5/8. That can't be reduced, so we're good with the fraction part of the problem. When we come to the whole numbers, 4 plus 5 is 9. We're good with the whole number side. And our final answer then is 9 and 5/8. Now let's look at a couple more examples. This subtraction, this one's a little different. First because it's subtraction, but also because when we look at this, we can't do 5/12 minus 7/12. So, since we can't do that, just like we would in subtraction with whole numbers, we have to borrow. The 6 becomes a 5. This borrowing process is where a lot of people get messed up because they want to make this 5 into a 15. They want to do this. That's wrong. Because what you're borrowing is actually one whole. So now we borrow and we have 1 and 5/12. Change that to an improper fraction. 12 times 1 is 12, plus 5 is 17. So we get 17/12, and I like to rewrite this part under it. So I'm going to come and rewrite this, minus 7/12, and that's going to give me 10/12. 10/12 I can simplify because both of those can be divided by 2 to give me 5/6. There's nothing else I can do on the fraction part of this problem. So my fraction part of the answer is 5/6. My whole number part is, remember I borrowed from the 6, it's not a 6 anymore, it's a 5. 5 minus 2 is 3. So my final answer for this problem is 3 and 5/6. I want to do one more example. 9/10 plus 7/8. Again, we look at our denominators, they are not the same, so I need a number that 10 and 8 both go into. I usually look and say, well, my bigger denominator is 10, let me think about multiples of 10. 1 times 10 is 10, well, 8 doesn't go into that. 2 times 10 is 20, but 8 doesn't go into that. 3 times 10 is 30, 8 won't go into that. 4 times 10 is 40, 8 will go into that. So 40 is a common denominator. Now, some people like to just say, well, 10 times 8 is 80 and use 80. And that'll work, but then it gives you bigger numerators to deal with, and that can be a little bit hard sometimes. So I like to use the lowest common denominator. So now we have to change to equivalent fractions. 10 times 4 is how I get 40. So 9 times 4 is 36. 8 times 5 is 40. 7 times 5 is 35. Now I'm ready to add them. And if you need to come over to do some side work over here, that's fine. Just don't do it over in the middle of the problem. Do it over to the side. 6 plus 5 is 11. Carry the 1. 3 plus 3 is 6. Plus 1 is 7. And so I get 71/40. Well, that's an improper fraction because the numerator, 71, is bigger than our denominator of 40. 40 goes into 71 one whole time with 31 left over. So 1 and 31/40 is our answer for this problem. And there's no whole number, so I'm done. If you need to go back and review this, please go back and listen to parts you might need to hear and see again. And then perhaps go ahead please and try the other problems on page 34. And come prepared with questions tomorrow.